So we will start the today's session. So this is a session 9, and in this session we will solve the previous year gate questions. So this is the first question. Am I audible to everyone? Am I audible?
Yes, sir.
Okay. So this is the question 22 which came in gate 2014 in the year set 1. So the question says the amount of CO2 generated while completely oxidizing 1 kg of CH4 to the end product is. So in this question they are asking that the amount of CO2 that will be generated while oxidizing 1 kg of CH4 to the end product is. So before solving this question, in this question basically we should know the chemical equation, like when CH4 will be oxidizing. So this equation we should know: CH4 with O2 will produce CO2 plus H2O. So in this equation we have to balance it as well. So here C is 1, C1, H is 4. So here it will be 2H2. Since now O2 became total 4, so here it will be 2O2. Okay. So this is a major thing which we have to which we should know basically before solving this question. So here in this, the CH4 molecular weight, we know this is a 16 gram. Okay. So molecular weight of CH4 is 16 gram, and the molecular weight of CO2 is 44 gram. So 12 plus 32. Okay. So here 12 plus 4, 16 gram. This is, I think, basic. So you know how to calculate the molecular weight of CH4 and how to calculate the CO2. So this is a 16 gram and 44 gram. So basically from the equation you can see 1 mole of CH4 gets completely oxidized and form 1 mole of CO2. Okay, since we know 1 mole of CH4 when get completely oxidized and form 1 mole of CO2, so therefore we can write this way also: 16 gram of CH4 forms 44 gram of CO2. Okay, since it is 1:1 ratio, so we can write 16 gram of CH2 forms 44 gram of CO2. Okay, so in next slide we will go. So if we can say, like, I will write it again: 16 gram of CH4 produces 44 gram of CO2. Okay, so how much will be 1 gram? Just a unitary method. 1 gram of CH4 will produce 44 by 16 gram of CO2. Okay, now in the question they have mentioned the amount of CO2 generated in kg while oxidizing 1 kg of CH4. So for 1 kg, if it is for 1 gram of CH4, 1 kg is equal to 1000 gram. So for 1000 gram of CH4 will produce 44 by 16 multiplied by 1000 gram of CO2. So basically we will get, if you calculate it, we will get 2750 gram of CO2. Okay, so basically CO2 formed after oxidizing 1 kg of CH4. You can write 1 kg or you can write 1000 gram, both are same. So we'll produce 2.750 kg of CO2. Here you have to see the unit because in this question they have mentioned in kg. So you have to report in terms of kg. So the answer is 2.750 kg. So is it clear? So is it clear to all of you? Anyone?
Yes, sir.
Okay. So for the next question, we will move on to the next question. So the next question says the dominating microorganisms in an activated sludge process reactor are. So the first option they have mentioned aerobic heterotrophs, anaerobic second option is anaerobic heterotrophs, the third option is autotrophs, and the fourth option is phototrophs. So hereby we will first understand what is meant by first aerobic, anaerobic, then we will understand what is meant by heterotrophic, autotrophic, and phototrophic. So beginning with what are aerobic reactions? Aerobic reactions. Aerobic reactions takes place in the presence of oxygen. Takes place in the presence of oxygen, free oxygen. Here you should write free oxygen. Takes free oxygen and produce reasonable, stable organic products. Stable inorganic end products. Inorganic end products with relatively low energy content. Low energy content. So basically, in aerobic reactions, what happened? Whatever reaction we say aerobic, that means it is occurring in the presence of free oxygen, and the end product are inorganic end product like CO2. It is an inorganic compound. So with reason and the end product which is formed, it has a very low energy content. Okay. So this is what we call as aerobic reactions. Now second, anaerobic reaction. Anaerobic. Anaerobic reactions. Anaerobic reaction basically occurs in the absence of free oxygen. These reactions occurs in the absence of free oxygen. Okay. Now this is aerobic reaction. Now we will know what are autotrophs. Oh, before autotroph, I should explain you the anaerobic bacteria, aerobic bacteria. Aerobic bacteria we will discuss. Aerobic bacteria. So aerobic bacteria basically bacteria that utilizes oxygen for growth and oxygen based metabolism is called aerobic bacteria. So I will write it bacteria that utilizes oxygen for growth and oxygen based metabolism. Okay, these we call as aerobic bacteria. Previously, I explained what is aerobic reaction. Since aerobic reactions occur in presence of oxygen, so here the aerobic bacteria means bacteria that utilizes oxygen for growth and oxygen-based metabolism. Okay, now anaerobic bacteria. Hmm. Anaerobic bacteria means bacteria that do not utilize free oxygen for growth. Bacteria that do not utilize oxygen for growth. Okay, so this is anaerobic bacteria. Now we will talk about autotrophs. Autotrophs. Okay, autotrophs are the microorganisms which derive both energy and material from the inorganic substances. They derive energy and material from inorganic substances. Okay, inorganic substances are CO2, H2O. Okay, inorganic. Now, if we talk about heterotroph basically heterotrophs. Heterotrophs are the microorganisms which derive both energy and material from the organic compound. So they derive energy and material from organic compound. Okay, so basically organic compound. So basically heterotrophs, they rely on consuming other organisms in the food chain. These heterotrophs, they rely on consuming other organisms in the food chain. Okay, so this is autotroph and heterotroph. Now phototroph. What is now we will go to phototroph. Phototrophs basically, as the name suggests, phototrophs they utilize sunlight as the energy source and the inorganic substances for the material source. User utilizes sunlight as energy source. Okay. Now we will go back to the question. So the dominating microorganisms in an activated sludge process reactor are, so the options are A aerobic heterotrophic, B anaerobic heterotrophic, C autotrophic, D phototroph. So in activated sludge process we know that it is a combination of aerator, aeration, primary sediment aeration will be there, then followed by the secondary sedimentation tank. So obviously oxygen is there. So the oxygen, so it will be aerobic and heterotroph. It will be aerobic heterotroph because heterotrophic organisms rely on consuming other organisms of food chain. So they consume organic matter. So the microorganisms which are dominating in ASP are the aerobic heterotrophics. Okay, so option A is the correct. Is this under? Is this clear? Is this clear?
Sir.
Okay. So again, I will explain. So basically, the dominating microorganism and activated sludge process in the reactor are, so the out of the four options, the first option is correct because in activated sludge process, aeration happens. So obviously, the microorganism will be aerobic, and it is heterotrophic because microorganisms present in the activated sludge process are responsible for the organic matter removal. So that's why aerobic heterotrophic, because organic matter is removed by the heterotrophs. So these, first of all, organic matter is removed by heterotrophs, and it will be aerobic because aeration happens in the activated sludge process. So it will be aerobic heterotrophic bacteria. So this is all about, as I mentioned, aerobic reaction involves presence of free oxygen, and anaerobic reaction occurs in the absence of free oxygen. So aerobic bacteria, they utilize oxygen for their growth and oxygen-based metabolism. Anaerobic bacteria, they do not utilize oxygen for the growth. Autotrophs, they derive energy and material from the inorganic substances. Okay. Heterotrophs, they derive energy and material from the organic compound. So wherever heterotrophic microorganisms will grow, there will be organic matter removal. So and they rely on consuming other organisms in the food chain. Phototroph basically utilizes sunlight as an energy source. Okay, and there are couple of other things also you should know this. One is aerobic heterotrophs. So this was the answer. So aerobic heterotrophs means basically aerobic bacteria. Aerobic bacteria utilizes oxygen in the utilizes organics in the, this will be organics bacteria which utilizes organics in the presence of oxygen, organic, or you can say organic matter. Okay, aerobic and similarly anaerobic bacteria, anaerobic heterotroph also exist. Anaerobic heterotroph, So as the name suggests, it will be anaerobic bacteria utilizes organics in the absence of oxygen. Okay, so they utilizes organics in the absence of oxygen. Okay, so these are the things you should remember. So okay, now we will proceed to the next question. So then the next question says 16 ml of water is flowing through a 2.5 kilometer long pipe of diameter 45 centimeter. The chlorine at a rate of 32 kg per day is applied at the entry of this pipe so that disinfected water is obtained at the exit. There is a proposal to increase the flow through pipe to 22 mld from 16 mld. So 22 mld from 16 mld. Assuming dilution coefficient n is equals to 1, the minimum amount of chlorine to be applied to achieve same degree of disinfection for the enhanced flow is. So basically they are saying there is a pipe 16 ml of water. This is a 2.5 kilometer length pipe. Okay, so this is 16 ml of water. It is treating 16 ml of water flowing through a 2.5 kilometer pipe. The diameter they are mentioning here is 45 centimeter. The chlorine at a rate of 32 kg per day is applied at the entry of the pipe. So at the entry, 32 kg per day of chlorine is applied. Okay, so that the disinfected water is obtained at the exit. So now the water which is at the end point, it is disinfected water. Now the water which is coming out from this pipe, it is disinfected. Okay, now they are saying there is a proposal to increase the flow through the pipe. So there is another pipe of same length. Now they are telling if there is a proposal to increase the flow rate, that is 22 mld. So assuming the same dilution coefficient, the minimum amount of chlorine to be applied to achieve the same degree of disinfection. So basically they are saying what will be the chlorine x kg per day to achieve the same degree of disinfection. Okay, so in this question, so after increasing the flow rate, they are asking the content of chlorine. So suppose this is the x kg per day, so they are asking the value of this, what is will be the Cl2. Okay, so now we will proceed for this. So the way to solve this, to achieve same degree of disinfection, to achieve same degree of disinfection for just hmm, for same degree of disinfection, this is whenever there is a question related to disinfection, always go to the Chick-Watson law. So for same degree of disinfection, C raised to power n T will be constant. Okay, so C here means the concentration of disinfectant, concentration of disinfectant, and the T here means here time required to kill, time required to kill microorganisms. Okay, and n is the dilution coefficient. Here the raised to power n, this is dilution coefficient. Okay, for same degree of disinfection, C raised to power n T is constant, where C is the disinfection concentration of disinfectant and T is the time required to kill microorganisms. Okay, here they have mentioned the assume the dilution coefficient is equals to 1. Okay, so we can write like, so we can write uh, if it is C, it is n equals to 1, so obviously Ct is equals to constant. Ct is equals to constant, product of concentration into the time taken to kill the microorganism is constant. So we can write therefore C1 T1 is equals to C2 T2. This is before flow rate and after increasing the flow rate. Here it is time. So T is equal T. So we can write T1 as L by V, which is L is the length of pipe and V is the volume of velocity of flow. V is the velocity of flow. So from this equation, this is a major equation. Okay, we will put it at start. So from T, we can write it as L by V. L is the length of the pipe. V is the velocity of the flow. So similarly, we can write for we know that Q is equals to AV, area into velocity. So from if we want to write V, we can write it as Q by A. Okay, if we substitute the value of V here, so it will be Q by A. So we can write T1 is equals to L A by Q. Is it clear till here? Is it clear till here? Uh,
Yes, sir.
uh, is should I repeat once again? Anyone?
No, sir.
Okay. Hmm. So T1 is equals to L by Q. So basically T1 we wrote as LA by Q1. Q1 it will be Q1 because flow rate is changing after, like initially it was 16 mld, later it was 22 mld. Okay, and the concentration we can write is W by Q1. C1 is W by Q1. W is equals to weight of disinfectant per day. Weight of disinfectant, weight of disinfectant per day, and Q1 is the discharge per day. So initially what we write, C1 T1 is equals to C2 T2. So we will replace the expressions in this final equation. So C1 will be W1 by Q1 into T1 will be LA by Q1. Okay. Similarly for C2 also we will write W, since they are asking what will be the disinfection amount. So it will be W2 by Q2 and it will be LA by Q2. A and L is constant, since they have nothing mentioned about the pipe, that whether they are changing the diameter on the length. So it is, we can assume that this pipe is same. So LA will be constant. So obviously, so this and this will get cancelled. Okay. So now since this, and if we write, can I write W2 is equals to W2, if I have, since I have to calculate the disinfection amount per day, W2 and Q2 square it will be. So can I write like this, Q2 by Q1 square into W1. So in, so I think it is, you are able to understand. So in terms of W2, if I have to write this, so I am shifting Q2 square basically here in this side. So we can write at the end W2 is equals to Q2 square. So Q2 square they have mentioned as 22 mld. 22 divided by Q1 is 16, and the initial rate of loading is 32 kg per day chlorine. So this whole square into 32. So if you solve this, you will get 62, 32 kg per day. So if you solve this, you will get 60.5 kg per day. So W2 will be 60.5 kg per day, and the answer will be option A. To achieve same degree of disinfection, this should be the rate of disinfection. Is it clear? This is it clear?
Yes, sir.
Okay. So okay. So once again, I will explain this. So basically, in this question, they are asking that they have some pipe. They have mentioned the diameter and the length. They are asking. They are telling that the if this is the initial water amount of water which is flowing, and this is the rate of chlorine which is applied. What is the amount of chlorine that they need to apply if the flow rate is increased to 22 mld? So for same degree of disinfection, they are telling for same to achieve same degree of disinfection. To achieve same degree of disinfection, C and T is constant. C is the concentration of disinfectant. T is the time required to kill the microorganisms. Now, so from T1 is equals to LA by Q1. From here LA because here just a second. So yeah, Ct is equals to constant. C1 T1 is equals to C2 T2. T1 we know time is equals to length by velocity, speed into time, distance is equal to speed into time basically. So for time is equals to L by V, length of the pipe by velocity of flow. Velocity of flow we can write as Q by A. So we are substituting this entire thing in this equation. Once we substitute it, we will get everything. We can write in terms of W2. After writing in terms of W2, after substituting the values which are given in the question, we are getting this answer. This is the rate of chlorine that need to be applied to achieve the same degree of disinfection. Okay. Now we will proceed to the next question. So in the next question, they are telling a suspension of sand-like particle in water with particles of diameter 0.1 mm and below is flowing into a settling tank at 0.1 meter cube per second. Okay. Assume G is 9.81 meter per second square. Specific gravity of particle is 2.65 and kinematic viscosity of water is this much. The minimum surface area required for this settling tank to remove particle of size 0.06 mm and above with 100% efficiency. Okay, so we will proceed to how to solve this question. Initially, I will write what are the data they have mentioned. So flow rate they have mentioned 0.1 meter cube per second. G is equals to 9.81 meter per second square. GS is equals to 2.65 and kinematic viscosity they have given as 1.0105 into 10 raised to minus 2 unit is centimeter per second, centimeter square per second. So minimum surface area required for the silting sand to remove. So whenever this kind of question comes, our approach should be the basic concept which I have discussed many times in the class, like overflow rate. We know overflow rate is equals to Q by A and it should be less than the settling velocity. For removal of the particle, the overflow rate should be less than or equal to of the settling velocity of 0.06 mm particle. Okay, so this is the overflow rate. So overflow rate should be less than or equal to the settling velocity of the particle, and overflow rate is equals to Q by A. So Q by A is less than equal to settling velocity. It should be set. So for 100% removal. So in the question they are mentioning above with 100% efficiency. For 100% removal, okay, overflow rate should be less than settling velocity. Now we have to first find the settling velocity. The formula for settling velocity is equals to Vs is equals to gamma s minus gamma w d square by 18 mu. So you can write it as also like that, gs minus 1 rho w g d square by 18 mu. So again you can write it as gs minus 1 g d square by 18 mu. The difference of these expressions are, if you consider this expression, it is here dynamic viscosity. But in this expression, since rho w I have considered in this only, so it is a kinematic. Okay, be very careful while writing the expression of settling velocity. In question, they have mentioned about kinematic viscosity of the water is. So, so we will take this as an expression. So, settling velocity is equals to gs minus 1 g d square by 18 mu kinematic. This is the kinematic viscosity. Okay. Now, so basically in this question, this is our main equation. After calculating the Vs and substituting the value of flow rate, we can easily calculate the area. So this you remember. So Vs we will calculate as G value they have given as 2.65. 2.65 into 9.81. Diameter they have given as 6. Diameter of the particle to remove is 0.06 mm. Okay. So 0.06 we have to convert it into meter. 0.06 mm divided by 18. Kinematic viscosity they have given as 1.0105. 5 into 10 to minus seconds meter square per second. So here they have mentioned in terms of centimeter square per second. I am converting everything in terms of meter per second. Okay. So everything, this also I converted into meter, and here also I am converting into meter square per second. So if you solve this, we will get a value of 3.2036 into 10 ratio minus 3 meter per second. Okay, this is our settling velocity. Now from the same expression we can write q by a should be less than equal to vs. This is what I have discussed in the few minutes back. So if we substitute the value of q the value they have given as 0.1 meter cube per second. So we will substitute 0.1 meter cube per second. Surface area is this. Just now settling velocity is 3.2036. 3.2036 into 10 ratio minus 3 meter per second. So basically we can, area, for calculating area we have, expression will come out as 0.1 meter cube per second divided by 3.2036 into 10 to minus 3 meter per second. So basically the a minimum will come out to be, if you solve this equation, 31.214 meter square. Okay, so this will be the final answer. So again, I will summarize this. So they have given the question. So they have given the basic details. What is the flow rate, and they have given the specific gravity of particle, kinematic viscosity of the water, and they are asking what will be the minimum surface area required for the settling tank to remove particle size of this much mm, and above with 100% efficiency. For 100% efficiency, we know the basic concept. Overflow rate should be less than equal to settling velocity. So using the same concept, we first calculated the value of settling velocity, and then we placed the value in this expression, and we have the value of q in the question. From there, we calculate the value of A, surface area. This is the minimum surface area. Is it, anyone has any doubts? So is it clear?
Yes, sir.
Okay. What about others? Okay. So this will be the 18th question. So the 18th question, the surface water treatment plants operates round the clock with a flow rate of 35 meter cube per minute. The water temperature is 15 degrees Celsius and jar testing indicated an alarm dosage of 25 milligram per liter with flocculation at a GT value of 4 into 10 to the power 4 producing optimum results. So this is the mixing gradient and the alum quantity required for 30 days of operation of the plant is. Okay. So in this question, so they have mentioned the surface water treatment plant operates round the clock with the flow rate. Flow rate is 35 meter cube per minute. Okay. The water temperature is 15 degrees Celsius and the jar testing indicated an alarm dosage of 25 milligram per liter. So alarm dosage is 25 milligram per liter with flocculation at a GT value of 4 to 10 to the power producing optimum result. The alum quantity required for 30 days in kg of operation of the plant is. So okay, so basically they are asking for alum. So alum quantity required for 30 days. Okay, so here first of all we should calculate the what will be the flow rate for 30 days. Okay, flow rate, it is given in meter cube per minute. We will calculate it meter cube per day. So basically 35 into 24 into 60. Now it came out in terms of meter cube per day. Okay, per day it means it is in terms of per day. The total number of days is 30. So we will multiply it with the 30. So and for the alum dosage required will be 25, 30. So this will, so alum dosage is 25 milligram. We need in terms of kg. So 25 into 10 ratio power minus 6 to get kg. The answer will be 37,800 kg. So basically, what we did in this question, nothing but we simply use the data given in the question and we just change in terms of meter cube per day. So basically, this thing, this up to this, it is in meter cube per day. Then we multiplied this meter cube per day into total number of days, total days. Okay. Then we multiplied that with the alum dosage. So alum quantity required for the 30 days is 37800 kg. So is it clear? Anyone has anything, any doubt?
No, sir.
Okay. So I will once again summarize the today's session. So basically, we started with this question where we have to calculate the amount of CO2 generated while oxidizing 1 kg of CH4 to the end product. So in this type of question, we should know the chemical reaction involved. So CH4 upon oxidizing producing CO2 and 2 and H2O. So based on the after mass balance, we came to know 1 mole of CO2 will oxidize 1 mole of 1 mole of CH4 after oxidation will produce 1 mole of carbon dioxide. So using that thing, we wrote 16. So here you can write basically 1 mole of CH4 will produce 1 mole of CO2. Okay, so using this we can write as 16 gram of CH4 will form 44 gram of CO2. So this is the molecular weight is 44 gram. Okay, so 16 gram of CH4 produces 44 gram. So for 1 gram of CH4, 44 by 16 gram. Since the question is asking about 1 kg, 1 kg basically means 1000 gram. So 1000 gram of CH4 will produce this much amount of CO2, this 2750 gram of CO2. But the question is, in question they are asking in terms of kg. So that's why it will be 2.750 kg. In GATE, always uh, first see the unit, and based on that only you report your answer. So it is 2.750 kg of CO2. In the second question, the dominating microorganisms in an activated sludge process reactor are they are given four options: aerobic heterotrophs, anaerobic heterotrophs, autotrophs, and phototrophs. So in this, we first discussed what is aerobic reactions. Like it takes place in the presence of free oxygen and produce reasonably stable inorganic end products with relatively low energy content. Okay, so in anaerobic reaction, it is occurs in the absence of free oxygen. So what is meant by aerobic bacteria? Bacteria that utilizes oxygen for growth and oxygen-based metabolism. And what is anaerobic bacteria? Bacteria that do not utilize oxygen for growth. Okay. Now I discussed about food autotroph also. What is autotroph? They derive energy and material from the inorganic substances. Heterotroph means they derive energy and material from the organic compounds. Okay, the difference between both the thing is it is inorganic substances they derive. However, in heterotroph it is organic compound from there which they derive the energy. Okay, autotroph basically they rely on consuming other organisms in the food chain. Now I discuss phototroph. Phototroph utilizes sunlight as an energy source and inorganic substances for the material source. Okay. Aerobic heterotroph basically means aerobic bacteria utilizes organic matter in the presence of oxygen. Anaerobic heterotroph means they utilize organics in the absence of oxygen. Since in ASP is the complete setup of aeration tank with secondary sedimentation tank. In aeration happens, so it will be aerobic. Since ASP is responsible for the organic matter removal, it will be aerobic heterotrophs. Okay. Now, in the second question, we discussed that they are initially measuring. There is a pipe in that the initial flow rate is 16 mld, and they are injecting chlorine at a 32 kg per day. Now, in the question, they are asking what will be the minimum amount of chlorine that need to be added when flow rate is increased to 22 mld, considering to achieve the same degree of disinfection. Okay, to achieve same degree of disinfection, I discussed C and T, C ratio over N, T is equals to constant, where C is the constant, is the Chick-Watson law. So whenever a question comes from the disinfection, always think of the Chick-Watson law. So C ratio over NT is equals to constant. C is the concentration of disinfectant, where T is the time required to kill microorganisms. And the N is the dilution coefficient, where in the question N they have mentioned as 1. Now Ct constant, C1 T1 is equal to C2 T2. T1 we can write as L. So basically unitary method we write distance is equal to speed into time. This is what I wrote. Time is equal to length of pipe divided by volume velocity of flow. T1 is equal to L divided by Q by A. T1 is equal to LA by Q. So velocity we can write Q is equal to AB. We can write V as Q by A. Substituting that, we wrote T1 is equal to LA by Q1. So, and C1 is the W1 by Q1, weight of disinfectant per day by discharge per day. So, this is our main equation. We have substituted these things here. Okay. W1 by Q1, LA by Q1 is equal to W2 by Q2, LA by Q2. LA will get cancelled because the length and the area diameter of the pipe is same. So, but the flow rate is different. W1 rate of injection, this we know. Q1 also we know, given in the question. Q2 also we know, that is given in the question. We don't know the value of W2. So this is what we have to find. So to find the W2, we wrote in this form where we substituted the given values and we got W2 is equals to 60.5 kg per day. Okay, so rate of disinfection that need to be added is 60.5 kg. So option A is correct. Now question 46. In this question they are mentioning they have given the a suspension of sand-like particles in water with particles of diameter 0.1 mm and below is flowing in a settling tank at this much flow. Assuming G is equal to 9.8, specific gravity and other details they have mentioned. So at the end they are asking the minimum surface area required for this settling tank to remove this particle of size this 0.06 mm and above with 100% efficiency. We know basic concept that for 100% efficiency overflow rate should be less than the settling velocity. Simply, we use that basic concept. We first calculated the settling velocity. After calculating the settling velocity, we substituted that value in this expression, and we also substituted the value of Q, which is mentioned in the question. So this is what I am talking about. So from here, we calculate the value of area, that is A minimum. Now in the last question, a surface water treatment they are asking operates round the clock with a flow rate of 35 meter cube per minute. The water temperature is 15 degrees Celsius and jar testing indicated an alarm dosage of 25 milligram per liter with flocculation at GT value of 4 into 10 to the 4 producing optimum results. The alum quantity required for 30 days of operation are so Q is equals to 35 meter cube. This is the given in the question. Q is 35 meter cube per minute. Alum dosage they have mentioned as 25 milligram per liter. So for alum quantity required for 30 days, we will calculate 35 into 24. So this is given in terms of meter cube per minute. We are converting this meter cube per minute into meter cube per day. So this is the thing which is in meter cube per day. Now we are multiplying with total number of days. 30 days they are asking. Then this is the quantity of alum. To know the quantity of alum required for 30 days. This is for 1 day they have mentioned. Per minute they have mentioned. Okay. So milligram per liter, and so this we got as a final result 37,800 as kg. This much of alum required for the 30 days. So this is for about today's session. If anyone has any doubt or anyone wants me to explain some other concepts in the next class, you can say.
So in the last question,
Hmm?
question number 4, there is no need of GT value.
Yeah, there is no need of GT value.
Okay, sir.
Yeah. Okay. So if you want me to explain some other concepts, you can convey me. So in the next class, I will try to address those concepts. Okay. If you want to leave, you can leave. This is the session. Today's session ends here. If any, I will be here till 7. If anyone has any doubt, you can ask.
Sir, alkalinity question, sir. Next.
Alkalinity questions. So total hardness and total alkalinity basically.
Yes, sir.
Okay, I will solve those questions, and I will tell like even I want to tell you like you can refer the previous videos also where I have explained all those concept alkalinity and hardness. In session 1 or 2, I have explained, and all those videos are have been uploaded in YouTube.
Okay, sir. Okay.
Yeah. Anything else? So you can see the previous lectures in the YouTube as well. All the videos I have uploaded. So you can read those. You can, if you have any doubt, you can ask. So next class also I will discuss about alkalinity questions. So if you want to leave, you can leave.